In this video, I'll show you how to solve the ALEKS problem called naming ionic compounds with common polyatomic ions. This problem is going to give you a cation and an anion. It's going to ask you to name it and also to come up with the empirical formula for that compound. There's going to be a couple of tricks to this problem. It's not going to be super straightforward. Let's start by coming up with the empirical formulas for these compounds. When we're combining cations with anions to make an empirical formula, one of the tricks that we have is that the charge of each ion tells us the quantity of the other ion. So since we have a 2+ charge on the chromium ion here, that means that we're going to need 2 of these Bro3- anions. And since this has a -1 charge, that tells us that we only need 1 of this chromium cation. So let's start with that. Our chromium, we know that we only need 1 of that particular ion because of the -1 charge. The 2+ charge on this cation tells us that we need 2 of these ions. And so since we need more than 1 of the ions, the formula Bro3, we're going to need to put that in parentheses so that we can kind of keep that together as a set. And then we'll put that 2 on the outside of the parentheses. That little 2 there is letting us know that we need 2 of these Bro3 units. Let's practice that again with our next one. We have a 2+ charge, so that means that we want 2 of the Io3- ions. The -1 charge here tells us that we only need 1 of the Mg ions. So this is Mg. We want to use parentheses, put that polyatomic ion inside the parentheses, and then the quantity on the outside. If you only needed 1 of a particular polyatomic ion, like if you didn't need this 2 out here, if this only needed to be a 1, then the parentheses would not be necessary. You only need to use these parentheses when you need 2 or more of the polyatomic ion. Our last one, we have zinc, which is the 2+ charge, so that means we're going to need to have 2 of those polyatomic ions. One mistake that I see students make relatively commonly is that they try to take this 2 like math and sort of multiply it out. So maybe they think that it would be okay to just say CrBr2O6. So they're kind of treating it like a math problem. And even though that is accurate in terms of the quantity of atoms, that is not the way we express these formulas, so don't do that. You want to keep these units exactly the way that they are. So that's our first challenge, and then the second challenge we have is coming up with the name. And we know when we're naming ionic compounds, we want to name the cation first, followed by the name of the anion. And if we have anything that is in this area on the periodic table, this is our area where we have unpredictable charges, we need to use the Roman numerals or Roman numbers to indicate the charges on those ions. Now, there are 2 exceptions to this rule of using the Roman numbers. One of them is with the zinc, and the other is with silver. These 2 particular metals, you don't need to use Roman numbers, and in fact, you can't in ALEKS, or it will be wrong. So for these 2, no Roman numbers at all. Okay, so for our first one, we have chromium. It is right here. It is in an area where we have to use Roman numbers to indicate the charge. The charge is a 2+, so we're going to say chromium with a 2 in Roman numerals, no space there. We're just jamming this whole thing together in parentheses. And now we have to say the name of the anion. This is a polyatomic ion. This particular polyatomic ion's name is bromate. Now, you might be asked to memorize the names of the polyatomic ions. You might not be asked to memorize them. And even if you are asked to memorize polyatomic ions, some of the polyatomic ions in ALEKS are going to be different from the ones that you're being asked to memorize. You may not have all of them in your textbook, but you can look them up on the internet. They're all over the place. So you just look for a table of polyatomic ions, click on anything, like you click on an image. This is a pretty comprehensive one. There's a lot on here. There are a lot of polyatomic ions, so you might click on a table that doesn't have one of the polyatomic ions that's in your ALEKS problem, and just try a different table. Just keep looking until you find one that has everything in it. For our second one here, MgIO3, this Mg is in this area, which means we don't need to use Roman numerals in its name. So this is just magnesium. And then this polyatomic ion is iodate. And our last one is zinc. This is, even though it's in that blue box that I drew, it is one of the two that doesn't need a Roman numeral. NO3 is nitrate.